of changing dimensions. This should have been something that you learned in middle school, but I'm not going to assume that you know it, so we'll just kind of talk about it. Is someone outside my door? Okay. So describe the effect on the surface area and the volume of a prism if the dimensions are tripled. So the first thing I want to talk about is the formula. So the formula for volume is length times width times height. And the formula for surface area off of your purple little reference sheet, 2 times the length and the width plus 2 times the length and the height plus 2 times the width and the height, right? Because you're taking, like, if this is the height, this is your width, and this is your length, you have a bottom and a top. You have to find the area of that, plus a height and a length, plus the height and the width. That's where those come from, okay? So all you're doing is putting that into your calculator. So let's use these dimensions. So to find the volume originally, I'm going to take 7 times 2 times 4. And I find out that my volume is, anyone? Yeah, 56 units cubed. 56 units cubed. And I tried to put calculators on everyone's desk just to be like proactive, unless I knew for sure you had a calculator. Did I miss somebody? Yeah, just grab one. There's one on Fallon's desk. Okay, so 56 units cubed. The surface area. So in your calculator, to find the surface area, 2 times, let's see. So 2 times 14 is 28, plus 2 times 8 is 16, plus 2 times 28 is 56, 14, 40, let's see, 30, 20, sorry, 20, 40, 50, 60, 70, 80, 90. What is it? 100 or 1? Okay. So 100 units squared. So now we're going to take all those dimensions and what are we going to do to them? What is it saying to do to them? Triple. Triple means to multiply by what? Yeah, this means just to multiply by 3. So now my length is 21 and my width is 6 and my height is 12. So to find the volume, my new volume, we're going to call that our new volume, we have to take 21 times 6 times 12. Calculator bunny gets units cubed. Perfect. Okay. So for the surface area, we have to take 2 times 21 times 6 plus 2 times 21 times 12 plus 2 times. So I'm going to let you guys calculate that. You got 900? Yeah. So 900 units square. So let's talk about that. So when you multiply the dimensions by 3, so when you multiply or increase by 3 times, what happens to the surface area? What are you multiplying by, actually? What happens to the surface area? We'll compare them. I started with a surface area of 100, and I ended up with a surface area of, will you take your earbuds out, you guys? I ended up with a surface area of what? 900. So what am I multiplying by? Yeah, I'm multiplying by 9. Does that make sense? Well, we're talking about area, and area is squarea, as Miss Halstead used to say. Area is squarea. So if I'm multiplying by 3, if I'm increasing each dimension, Roxy, will you take your earbud out? If I'm increasing each dimension by 3, what is 3 squared? 9. That's why we multiply it by 9. So 3 squared equals 9. So using that same kind of idea, maybe, what do you think is going to happen to the volume when we multiply it by 3? So if we take our original volume and we multiply it by 3, the new volume is 3 cubed, right? Because volume is cubic. So what did we really multiply by? Yeah, we multiplied by 27. That's what we really multiplied by. Well, let's check that. What is 56 times 27? 1512. Okay.
1,512.
Yeah, which is what we got, right? So let's just write a little note. You square the multiplier. Does that make sense when I use the word multiplier for surface area? So if you're increasing your surface area, you square the multiplier. And if you're increasing the volume, you cube the multiplier. And that should make sense because volume is cubic and area is square area. That's how I remember that from some crazy old math teacher who I love. Okay. So hopefully we're not going to have to think really hard on the next one. Okay. So to find the volume and the surface area of a cylinder, let's see, volume pi r squared h, surface area, we have 2 pi r squared plus 2 pi r h. So let's do volume first. We're just going to find the original measures. So the volume equals pi, and we're going to leave our answer in terms of pi. We're just going to not even use pi in the calculations. Pi times my radius squared times my height. Well, 10 squared is 100, and 100 times 20 is, so 2,000, oh, sorry, that's on volume, 2,000 pi units cubed. Just leaving pi like as a variable. Just leave it as a variable. Don't even multiply that out. It's going to give you a bunch of decimals and we don't need that. Okay. Let's find the surface area. So for the surface area, I have 2 times my radius squared times pi plus 2 times my radius times my height times pi. Okay, so 2 times 100 is, so I have 200 pi plus 10 times 20 times 2 is 400 pi. Yeah, so the surface area is 600 pi units squared. So what are we doing to our dimensions? Halving our dimensions. We're cutting it in half. So half, well, that means that we take, for the surface area, we take 1/2 and we square it. So what is 1/2 squared? Yeah, it's 1/4. So 1/4 times your original measurement for surface area, 1/4 times your original measurement for your surface area. What's 600 divided by 4? Yeah, 150 pi units squared. So to find the volume, we're going to have to take that multiplier, 1/2, and we're going to have to cube it. So for the volume, let's see, what is 1/2 when I cube it? I didn't hear you. Yeah, it's 1/8. Awesome. So we're going to take it 1/8 times the original measurement, which was 2,000. And we're going to just drag the pi along. Don't put pi in your calculations. Don't include the pi. So what's 1/8 of 2,000? So 250 pi units cubed. I think that's so fabulous. Okay. So for number 3, you guys don't even have this formula on your sheet. It's asking you to find the surface area of a regular square pyramid. So I want to talk to you about surface area of a pyramid. So the surface area for a pyramid, well, we have the area of the base. So I'm just going to write that area of the base. That's this guy right here. Plus the area of the 4 triangles. Okay. The reason we don't have an exact formula is because that base could be different every single time, right? It could be a rectangle. Like right now, since it's a square base, I know that all 4 triangles are going to be congruent, but it doesn't always work like that. So the formula that I want you to use, this is what I want you to use. When you're calculating surface area of a pyramid, I want you to find the area of the base. And I write that as capital B. Usually we write base as a small b. I write it as capital B. Plus 1/2, because remember, to find a triangle, we take it like 1/2 times the base times the height. 1/2. If I find the perimeter of my base, if I find the perimeter of the base, isn't that all of the base measures added together? Whether they're the same or not, it's all of them. So 1/2 times the perimeter of the base times the slant height. So that cursive L represents the slant height. So again, I think that surface area of pyramids is the toughest shape always, just because those bases can be all kinds of different shapes. So when I'm looking for that capital B, the blessing is that it's a square. My base is a square, and it says that the length of each side is 9. So to find that area, I just have to take 9 squared. So capital B equals what? Yeah, so my capital B equals 81. So let's talk about the perimeter of my base. Perimeter, that's all the way around. So I have 4 sides, and they're all the same. So the perimeter of my base is 36, yeah. The slant height is always going to be given to you, or should always be given to you. So that slant height, L, well, it's 18. It's given to us, right? So I'm going to plug it all into this equation right here. So the surface area equals capital B, which is 81, plus 1/2 times my perimeter times my slant height. Well, half of 36 is 18, and 18 squared is 324. 324 plus 81 is 405. Yeah. So my surface area is 405 units squared. Well, are we making this larger or smaller? We're making it smaller by what dimension? 1/3. So we're talking about surface area. So what do I do to the multiplier when I want to find my surface area? What do I do to the multiplier? I square it. Yeah, surface area. I want you to say area is square area. That's what you always do to the multiplier. So you're going to square it. Well, 1/3 squared equals 1/9. So I'm going to take my original dimension and multiply it by 1/9. So 405, it's divisible by 9. That's what you're doing, really. What is it? 45. So what is your multiplier? Again, I'm going to just say, what are you multiplying by is what it asks. Square the multiplier. When you're changing the surface area, you square the multiplier. Whether you're making it bigger or smaller, you're still going to square the multiplier. If you're changing the volume, you cube the multiplier. Thoughts? Don't like it? Okay. Okay. Does anybody have any questions about that? Okay. I want to do the one on the back. I want to do number 4. So number 4 says that describe the effects on the surface area and the volume of a sphere. So let's write the formulas out. So let's see, the volume of a sphere. Anybody know it? Have it memorized? No? 4/3 pi r cubed. The surface area, which I think is really cool, is 4 pi r squared. 4 circles. 4 circles with the same radius equal the surface area of a sphere. It's really cool. If you took a perfectly round grapefruit or orange and peeled it apart and found the radius of your grapefruit, you could make those 4 circles and use all your peels and make exactly 4 circles. I've done that. I made a video of it. I know that's really nerdy, but that's how I work. Okay. So let's use the volume formula. It says our radius is 6. So I have 4/3 times my radius cubed. Again, I'm not putting pi in my dimension. I'm just going to tag pi along at the end. So 6 cubed is 216, right? I think. Is that right? 36 times 6 is 216. I don't know. And then take that and multiply it by 4/3. You guys do know how to do that in your calculator? Like how to put a fraction in there? Yeah? Parentheses, all that good stuff. Okay. What do we get? 288. So my volume is 288 pi units cubed. Okay. So let's talk about the surface area. Sorry, I didn't label that. So my surface area, well, I'm going to take 4 times my radius squared. I think that's 144. Yeah. So 144 pi units squared. Okay. So what's our multiplier? What does that mean? Double means to do what? Multiply by 2. Yeah, that's the same thing as saying multiply by 2. So I have to square the multiplier, which means 2 squared, 4 times 4. And I also have to cube the multiplier, which equals 2 cubed or 8. So I'm going to take this measurement and multiply it by 4, and I'm going to take this measurement and multiply it by 8. What are my new dimensions? 576 pi units squared. Thank you for that. And my volume? 2304 pi units cubed. What's the biggest takeaway from this lesson? When you want to change the dimensions, I don't care if you're making them bigger or smaller, you square the multiplier for surface area and you cube the multiplier for volume. That's it. That's all you do. I wish someone would have told me that when I was younger because it took me a long time to figure that out. So you don't have to show your work. If you know, like if you just know that you're squaring the multiplier or cubing the multiplier, just plug it in. Don't change. You don't have to physically change your dimensions. That's just a bunch of extra crap that you don't have to do. Okay. So you do have to finish the rest of page 18. You do have to finish the rest of page 18. Okay. So it's just asking you how the dimensions, like what happens to the dimensions of a cylinder if they're cut in half for the surface area? Well, find the surface area, right? So the dimensions of a cube are 5. You're not even finding this. So what happens to the dimensions of a cylinder if they're cut in half? Well, what's half? What do I do to surface area? I square it. Yeah. So 1/2 squared it means that you multiply it by 1/4. That's what you're doing. Multiplying by 1/4. Or you could say divide by 4. That's all it's asking you. Okay. So look and see if you're finding volume or surface area and just square those. Square or cube them. Okay. And that's all surface area. So I'm going to stop our video.